How are you feeling? Are you guys okay? It's not too bad, is it? Let's do one that maybe where it will flip, just so we can see it. Doop-de-doop. Well, that one doesn't necessarily have to flip. I'm gonna do one where it's debatable. Based on what you guys tell me, we may or may not flip this sign. And then I'll try to find one where you kind of get forced to flip it. Because remember, you can always approach the problem slightly different. You can choose to move things based on what makes you comfortable. Looking at this one, we have X on both sides. Well, we know the first thing is, if we're going to get X alone, we better get them on the same sides, right? Which one do you want to move? Do you want to move this one over here, the 4X to the left, or do you want to move 2X to the right? 4X to the left? Carmelita, I'm going to look and see what you said. What's your question?
I was just going to say move the 2X.
Is that what you guys said too, move the 2X? Oh, okay, good. Everyone's in agreement that we should move the 2X. It really doesn't matter. The idea is that when you move one, you just change the sign in front. So yeah, that's a good recommendation. Carmelita's agreeing with the whole class. Sorry, I'm not used to having cool microphone usage in this. Okay. So I'm going to move the 2X over. And I'll say negative 2X on the right. That's what happens when you cross over the border, right? When you cross over this sign, this thing cancels out. So now I'm going to rewrite everything I have. Has anything happened to my sign? No, it's still the same, isn't it? So I've got negative 9 greater than. Let's actually put these like terms together, though. What's 4 minus 2 give me?
Negative 2.
Okay, now actually it's a positive 2, and I heard you guys say because 4 minus 2 gives me the positive 2 plus 5. So yeah, still be careful with those, putting some positives and negatives if you do that. Now what? Subtract 5? Good. Do it to one side, you also do it to the other. Now we're subtracting 5x from both sides. Does the sign flip, or are we still A-okay? Still okay. So notice every time I've written the sign, it's staying the exact same. Nothing is changing. Second, negative 14 and 2x. I want x by itself, so I divide by 2 on both sides. And let's see, we get x less than, what is negative 14 divided by 2? Negative 7. That sounds perfect. And of course, if someone wanted to graph it, you could switch it, right? Like we discussed a second ago. You could put x less than negative 7. Right? Everybody good? They're the same thing. I can put an or here. But for graphing purposes, I would have wanted you guys to recognize. Yeah, Chelsea. Let's practice the other way just so we can compare. Let me extend the page. Hopefully, you guys have that in your notes. So I'm going to write it. I'm going to act as we made a different approach. And Chelsea, if you'll help me go through your steps, I bet we can find as a class what happens. Because it's true, even if you take separate steps, as long as you're not breaking any rules in algebra, it's okay to go different ways. Rules being flip the side when you have to, and when you do things, do it on both sides equally to everything. So let's see, this one was 2x minus 9 greater than 4x plus 5. So we're going to do the same problem a different way. Tell me what you did first, Chelsea. Okay, so you decided you wanted to go ahead and get the numbers together. That's completely legit. Nothing happens to my sign though, right? So I get 2x greater than 4x plus what? Okay. Okay. So then we want to do what? What do you do next? And Carmelita, I can hear you if you're checking. Okay, so you chose to subtract 4x? I'm glad you did that. I was wondering if you, okay. So we're going to move this over here. Basically what happens when you move it across the border is it changes signs, negative 4x, right? And then it cancels over here. All you do is change the sign in front as you shift it over. That's the way I'm promoting for you guys to remember it. A negative 4x and a positive 2x, what do we get? What have I done over here besides make this look horrible? Okay, I'm something like that. So you said negative 2x. Has the sign flipped or anything, or are we still okay? Still okay. So notice every time we brought the sign down, we were very careful to write it exactly like it was. I want x by itself. What shall I do here? A flag should go up in your brain when you said that to me. You're multiplying or dividing by a negative means you have to do what to that sign? Absolutely. So I get x, my sign has to flip. Let me use a color I haven't used. The sign flips. And in this case we're dividing, so I'll say because divided by a negative. And I'm going to get negative 7. And Carmelita, you can just speak if you want.
I have a question. Why did the sign flip?
Okay, so Carmelita asked why the sign flipped. Remember that when you're doing inequalities, the only time it's going to be different is if you multiply or divide by a negative number. So if you look at the two different examples we did, up here on the right, we were dividing by a positive 2, right? That's completely okay. Positive numbers do not change the sign at all. Adding and subtracting do not change the sign at all. But if you multiply or divide by a negative, like right here in this most recent problem, when we have 14 divided by a negative number, that's when the sign flips, because we divided by a negative.
Okay, thanks.
You're welcome. You guys okay with this? Yeah, except, well, when you graph it, it's not just one number. It's not x equals negative 7. It's, if you graph the thing, it's anything smaller than negative 7 was allowed. But yes, so you treat it the same way the whole problem, except at the very end, sometimes your sign will flip. And this is where people will mess up, because it can just, you know, it can be tempting to flip it too much or to just forget to flip it. Let's look at one that looks a little harder. Same idea, though. You flip the inequality. I'm going to write on top of this next page again. And notice I say any time you multiply or divide by a negative number. That's because guess what? This thing can flip more than once. Who cares? If it were to be a situation where I did that operation more than one time, I had a negative being times and negative being divided, it can flip a couple times. It won't. That's not a very common thing, but it can happen. Okay, so let's look at this one. I have no idea if it'll flip or not. It kind of depends on our approach, really, because we can, if we don't like negatives, it's pretty easy to avoid them. Well, with most problems, not always. What are we going to do? Okay, simplify. And Jennifer, you're thinking on the left first? That's where you naturally hit first? Okay. How do you do this? How do you simplify on the left? Okay, so wait. Oh, you were thinking on the other right. Okay. The right is actually is right. Okay, hold on, let me write this. 2x minus 4 is what we had. We wrote an example. And you were saying go ahead and share that 3? Sure. It doesn't matter, again, guys, which order you take. Negative 3 times 2x gives me negative 6x. Negative 3 times negative 4 gives me positive 12. Go ahead and continue simplifying that, please. Holly, if you have questions, just make it beep so that I'll know to check the chat, okay? Otherwise, just listen. Okay, so on the right, I'm going to put the 9x and the negative 6x together, right? Let's see, 9 minus 6 gives me 3x. We still have a plus 12. So we're just combining like terms like we would always do in algebra, even if we had the equals in the middle. That's always what you do. You simplify on the right, simplify on the left, then you deal with solving. Let's see, on the left, what shall we do to break down those parentheses? Okay, distribute the 5 through both pieces. Sounds good to me. So we get 5 times x is 5x. And 5 times negative 2 is negative 10. Okay, sounds good. Now what? Okay, we'll move one of them, right? Get the x's on the same side. Which one do you guys want me to move, the 3x or the 5x?
3x.
Okay, 3x. So when we move this over, it becomes minus 3x. So let's see, a positive 5 and a negative 3. 5 minus 3 gives me 2. So I have 2x minus 10. Does my sign flip, or do I just keep copying it down the same exact way? Keep copying it. Be really careful, too, because if you write it wrong, you're just messed up. You've got to be careful when you do that. Okay? I still want to solve for x, and again, I'm just treating it like a regular algebra problem where I want to isolate x. So looking on the left-hand side, I want to get rid of the least attached thing. I see a negative 10. What will cancel a negative 10? A positive 10. Because the opposite of negative is positive, or you can think opposite of subtract is add. So plus 10, if I do it to one side, I also do it to the other side. So I have 2x. My sign still is the same. The only time it would switch, remember, is if I multiply or divide by negative. And I get 22. Now I want x by itself. I have a 2 attached to my multiply. What shall I do? Divide by 2. Is that legit, or do I need to flip something? It's legit. We're okay. So x greater than or equal to 11. Isn't this way easier than the last 2 sections? I know. That's why I was like, let's clear our minds and do something new. You can even graph these, right? It's not hard to graph these. The only time it can get a little harder is when you start combining it, and even then it doesn't get much harder. So I'm going to show you that